Good afternoon, dear professors and instructors. We, as a team, me, Canan Ibrahimli, Emin Aliyev, and Yusuf Kurbanov, are excited to present our senior design project that we have been working on for the past 2 semesters. This is the outline of our presentation. We will cover the following topics. And let's start with our project proposal. While building enterprise applications, architects are faced with a choice between different application models. There is still no agreement on which is the best for various applications and scenarios. So, our project is about comparing two deployment models, namely monolithic and microservices architectures, in terms of performance, testing, and deployment in different settings. Monolithic architecture connects all application components on a single server, making it simple to develop and maintain. In contrast, microservices architecture breaks down the application into smaller independent services, making it flexible and scalable. The problem addressed by this project is the need for a comprehensive evaluation of the key metrics of monolithic and microservices architectures for enterprise applications. By evaluating different deployment models and their metrics, we will provide the strengths and weaknesses of both architectures, which will help businesses to select the best option for their needs.
I'm Emin Aliyev, and I will continue our presentation by introducing our solution to the problem. Before we evaluated the monolithic and microservices architectures for enterprise application models, we obviously needed to develop both of these applications with the same functionality. After we developed these applications, we started to take measurements for each application in different settings, including testing, deployment, and response times. Having all these metrics calculated, we proceeded to the evaluation process by identifying its strengths and weaknesses of each architecture. And finally, we concluded where each deployment model would be most suitable. Tech stack. When it comes to the implementation of our solution, we used a variety of modern technologies in the process. For the development of monolithic and microservices applications, we opted for Nest.js, which is a powerful backend framework to build scalable and efficient server-side applications. PostgreSQL, yet another powerful tool, was our database choice. On top of backend development, we also built nice and clean user interfaces with React. And finally, Docker was extremely useful in testing and deploying both the monolithic and microservices applications. Then here you see the use case diagrams, which provide a visual representation of the system's functionalities from the perspective of three actors, which are admin, customer, and business. Then the next is ER diagram. This is the entity relationship diagram of the system, which represents the entities and their relationships between each other, basically. Yep. The next is about monolithic architecture. In the monolithic architecture, we developed 11 Nest.js modules, which are contained in a single unit. Each of these modules can interact with the shared PostgreSQL database, and our front-end application interacts with this API via HTTP requests and responses. The application itself runs in a Docker container as a Node.js application, and it serves our React application as static assets. The next is about microservices architecture. In the microservices architecture, we developed 12 different Nest.js applications as microservices. Each of these microservices can interact with others via TCP or HTTP. Like in the monolithic architecture, we also share the single database here, which can be used by all of these microservices. In this application, we adjusted one of services as a publicly exposed API gateway, which enabled our React application to interact with the backend smoothly. Each microservice also runs in a separate Docker container as a Node.js application, but only one of them, which is called API service, which is also the API gateway, serves our React application. Although this architecture seemed hard to standardize our testing process, we managed to write and standardize more than 20 unit and integration test with just testing framework.
This is a user interface of our application. User can register as a customer and business by filling required fields. After registering, a confirmation link is sent to the user's mail address. By clicking this link, user confirms his account and is automatically logged into the application. User can also update his information and upload a profile photo. There are two ways of adding products to the cart. Here, customer can add products to cart by clicking Add to Cart button and by searching specific product name in the search box. From the navbar, customer can filter out products by categories. User can update the quantity of products in his shopping cart. He can also apply the discount by specifying valid discount code. Finally, he enters the billing details and check out the order. Let's talk about our front-end architecture. It's a single-page application powered by React. We have four main modules in the application: authentication, admin, business, and customer modules. Initially, when a user enters the application, authentication module takes over the routing of the application and redirects him to a specific module based on his role. In addition, each module interacts with our backend API via HTTP requests and responses. And finally, for our front-end end-to-end testing, we used Cypress, which is a modern and powerful testing framework for web applications.
I would like to start with challenges that we faced during the development and the deployment of our software. So during the initial software design phase, some issues were due to code bugs, which were easy to find, detect, and solve. But some of them were due to compatibility and functionality of certain application components. For instance, we faced an issue when the Prism could not disconnect from the database and while in the background running the jest test, and this caused some of our tests to fail. And additionally, there were times when our application components, Nest.js components, did not behave as intended as we desired, and this was due to functionality issues. Also, we had some architectural errors that resulted from the insufficient analysis of the development, and this forced us to turn back to the model and make some changes. And in that environment, we just waste time. However, the most difficult problem I would say was wage errors that did not provide us with enough information to find and solve the problem. For example, the issue with the prism that I mentioned earlier is still unknown to us. So, coming to the result part, which is essential part of our project, we use several methods to measure and evaluate the performance of our both applications in both environments, local and server environment, and we did it by calculating the mean, sample variance, standard deviation values, and also producing the normal distribution graphs, and all of them are written in our report. So I would like to start with the testing part. So testing time of the monolithic application in both environments, local and server environments, is lower than the testing time of the Microsoft application. So you can see from the table, and this shows us that Microsoft's application has a complex system with more, I will say, communication, with more coordination between its components, while monolith application is a more straightforward approach, more traditional approach. It's simple. And before talking about the deployment times, I would like to mention one point. Deployment process of Monolith and Microsoft's application without test and with cache in both environments is always faster than other ones because the cache stores the frequently used data in a cache memory. It's where it can be quickly accessed, and this makes our application faster since the system does not need to look for the needed data in the entire system every time. It just takes from the cache. And yeah, some interesting outputs there. There were few sets that got our attention. So in deployment numbers, usually our mean values are higher than the variance values. But when deploying the microservice application, only microservice application in the server environment without test and without cache, our variance values are higher. You can see normal distribution graph of such cases. And after researching, we as a group came to the conclusion that data points in that specific set are spread out from the mean. This means that there is a large difference between the individual value of the data points and the mean value. So this scenario is the same for all of these deployment times, and these are the, as I say, the normal distribution graphs of such cases. So coming to the hardware, to calculate all these metrics, we have measured the CPU speed in local and internet speed in the server. And we witnessed one interesting fact that the hardware directly affects both testing and deployment times, such as a higher CPU speed leads to the shorter testing duration in local, while higher internet speed almost compensate for higher CPU speed in local environment. So they compensate each other in local and in server. So to sum up, the project testing and validation outcomes show us that monolithic architecture is one step ahead of the microservice architecture in testing and deployment process. But I would say, although both architecture shows some similar HTTP response times for endpoints, for both of the endpoints, microservice architecture proves to be more efficient with handling the HTTP requests. So in general, these all results indicate that the monolithic architecture is more appropriate for certain types of the projects and use cases, while the microservice architecture is more suitable if you think that you will handle with HTTP requests more. So yeah, these are the team members and our contribution to the project. You can stop and look at the contribution, and yeah, these are the QR codes of our websites, and you can scan and visit our website. So that's all. I hope you liked our presentation. So thanks for your listening.